So today we are going to solve this problem, element appearing more than 25% in sorted array 1 2 8 7. So see, in this problem you are given a sorted array of integer. Exactly when a number appears more than 25% of the time, find and return that number. So that's it. So the problem says, see, you have array like 1 2 2 1 2 2 6 6 6 6 7 and 10. So there are total 9 elements. So 25% of 9 is 2.25. So now let's count each element. So 1 has came 1 time, 2 has came 2 times, 6 has came 4 times, 7 has came 1 time, and 10 has came 1 time. So see, 4 is greater than 2.25. Okay, so the answer is 6. Now let's take one more example. If the array has 1 1 1 2 5, 1 has came 3 times, 2 has came 1 time, and 5 has came 1 time. So there are total 5 elements. Okay, so 25 of 5 is 1.25. Okay, 1.25. So see, 3 is greater than 1.25. Okay, so the answer is 1. Now let's take one more example. If we have array like 3 3 3 3 4 5, 1 2 3 4 5 6. So there are total 6 elements. 25 of 6 is 1.25 is 1.5. So now let's count each number. 3 has came 4 time. Okay, 4 has came 1 time, and 5 has came 1 time. So 4 is greater than 1.5. So the answer is 3. Okay, so now what is meant by 25%? See, 25% means, so see, imagine in class has 8 students. Okay, so 25 of 8 is 25 by 4 2. So if any names appears more than 2 times, this is our special student. Okay, so now let's understand with colors. Okay, let's take this color. We have some colors like, first we have blue, 1 2 3 4 5, and red, 2 1 2, and this color, which color this is? Okay. Now see, we have 1 2 3 4 5 6 7 8. I think that, I don't know this color name, but it was pink, maybe light pink, anything. Okay, so we have 3 colors. Okay, blue, red, and this one, white. Okay, we have 3 colors. See, blue has appears 5 times. Okay, blue has appears 5 times. Blue has appeared 5 times. Red, and take white only. Okay, see, blue has came 5 times, blue has appears 5 times, and red has appears 2 times, white has appeared 1 time. Okay, so see, 5 is greater than 2. Okay, so it was special. So blue color is special, so we have to return this. Okay, now see, because blue appears more than 25% of the time, so the answer is blue. Now same like in numbers also, we have numbers like 1 1 1 2 3 1 2 3 4 2 3 4 5. Okay, so 1 has came 4 time, 2 has came 1 time, 3 has came 1 time, 4 has came 1 time, 5 has came 1 time. Okay, so 4 is greater than 2, so the answer is 1. So the special number is 1. Okay, so so the problem is, find a number that appears more than 1/4 of the total times. Okay, Now see, let's understand problem clearly. See, mm, wait. So what do I need to find? So we have to find a number that appears 25% of the time. Okay, see, there are hints. Okay, in this problem there are two hints. So the first hint is, so array is sorted. Okay, the array is sorted. And second hint is exactly one special number exists. Okay, so we have to return only one number. So there are total two hints that was helps us. Okay, so say what is the most observed way to solve this. Let me count every number one by one. Okay, so if we count if one number one by one, so whoever has the highest count, that's my answer. Okay, so this is a brute force. So the brute force time complexity is big O of n square. So it was slow and space is big of 1. Okay. So can I do better? Yes, so we can do it better. So array is sorted. So sorted array means we are going to use binary search. Okay, if array is sorted we are going to use binary search. Okay, or sorted array always think binary search. Binary search thinking, if one number appears more than 25%, it must show up that one of these show up three position. Okay, so show as three position, like see position 1 array of n by 4, and position 2 array of 2 into n by 4, and position 3 array of 3 into n by 4. Okay, see for each position find first occurrence and last occurrence. Okay, now count, we have to find first occurrence and last occurrence for each position. So count is equal to last minus first plus 1. So count, if count is greater than n divided by 4, so the answer. Okay, now let's, if we run we get it clearly. Okay, so why we only use three position? We use only three positions. See, imagine you have a long hallway with 8 doors. Okay, you have long hallway with 8 doors. See, wait, let me write numbers: 1 2 3 4 5 6 7 8. Okay, we have long hallway with 8 doors. So now one color paint more than 25% of doors. So we have, let me paint one color 25%. Okay, 3 4 5 and 6. Okay, now you will be understand clearly. So one color paint more than 25% of doors. So blue paint, so there was blue paint 4 doors out of 8. Now we divide hallway into 4 equal parts. Okay, so see part 1. So door is 1 and 2. In part 2, so there are door 3 and 4. So blue started here. Okay, and part 3 door 5 and 6. So blue is here too. Okay, in here also blue. And part 4 door is 7 8. Now see, blue point more than 25% of doors. So blue closed at least one full part. So that means blue is guaranteed to be at the start of the sum part. Okay, see, part 1 start at door 1. Okay, part 1 start at door 1, array of 0. And part 2 start at door 3, array of n divided by 4. So here, and part 3 array start at door 5. So array of 2 into n divided by 4. In part 4 start at door 7, array of 3 into n divided by 4. Now so we only check 3 position. Okay, so now we only check 3 position. So because our special number must appear at one of these stars. Okay, now see, when you saw 25% in the problem, you should think 25% means 1/4. Okay, 1/4 means divided by 4. 1/4 means divided by 4. Okay, so divided by 4 means equal parts. Whenever you see the problem in 25%, so 20, this means 1/4 divided by 4. Okay, so it means equal parts. So see, so you divide array into 4 parts. See, if we have array, so we have to divide like, see, 1 number 1 2 3 4 5 6 7 8. Okay, see, part 1 we have to divide, part 2, part 3 and part 4, like this. Okay, see, our special number appears more than 25%. Okay, that means it take up more than one full part, so it must cross into next part, which means it will be at last starting point of the sum parts. Okay, now see, starting points of each part. So array of n, array of 0 and array of n divided by 4 into n divided by 4 and same. Okay, so see, since the problem say 25%, I divide the array into 4 equal parts. So as 4 equal parts, and any numbers appearing more than 25% must appear at the boundary of the sum part. So I only need to check these 3 position. Okay, so see, simple, 25% means 4 parts, check boundaries, that's it. So that's it. Now let's take with example. Now I think I should take colors only. 1 2 3 4 5 red, and this color, let me take this color, and white. Okay, see, blue has appeared 5 times. Okay, and red has appeared 1 time, and this color has appeared 1 time, and white has appeared 1 time. So this is exactly what our problem wants. So find the colors that appears more than 25% of time. I am taking the example of colors, but there are numbers. Okay, so there are total 8 numbers. So 25 of 8 is 2. Blue appear 5 times, so 5 is greater than 2. So blue is our answer. Okay, now the idea is, in brute force we count every color one by one, so that was slow. See, but the smart way is, we know the array is sorted. So see, so color has grouped together. So first and last, so count is equal to last minus first. 1 is equal to 4 minus 1 is equal to 4 minus 0 and plus 1, that was 5. Okay, so the idea is the array is sorted, so the same numbers of group together. Find 3 candidate and count each one using binary search. Whoever crossed 25%, that's our answer. Okay, it was clear. Now see, now understand. 1 2 3 4 5 6 7 8. Okay, so the n is 8. So 25 of 8 is 2. We pick 3 candidate. N by 4 is 2. Array of 2. 1 2 3 4 5 6 7 8. Array of 2 is equal to 3. It was candidate 1 2 into n by 4, that was 4. Array of 4 is 3, so it was candidate 2. And 3 into n divided by 4, 6, so array of 6 is 6, so it was candidate 3. Okay, now we check candidate 1. Candidate 1 is number 3. Now let's see. 1 7 0 1 2 3 4 5 6 7. Okay, left is equal to 0, right is equal to 7. If we find mid is equal to 3. Okay, array of 3 is equal to 3, so save, so we go left, so mid is now 1. Array of 1 is 3, so save, we go left, and mid is equal to 0, so array of 0 is 1, so we go right, so we stop, so the first is 1. Okay, now we find last occurrence of 3 is 3. Left is 0 and right is 7, so mid is 3, so array of 3 is 3, so we save, so we go the right side, and mid is 5, array of 5 is 5, so we go left, and mid is 4, so array of 4 is 3, so we save, so we go right, so last is 4. Okay, last is equal to 4. Now we count last minus first plus 1, so 4 minus 1 plus 1, so 4 minus 1 is 3, plus 1 is 4, so the 4. Okay, so 4 is greater than 2, so see, so the answer is 3, so we did not even need candidate 2 and 3. Okay, so see how those the idea work. We pick candidate 1, array of n by 4, that was 3. We found first and last, first was 1 and last was 4. We count 4, so 4 is greater than 25% of, so we have to return 3. Okay, clear? I think it was not clear. Let me take one more example. Array, we have array, let's take small example, 3 3 3 5. Okay, so n is equal to 4, so 25% of 4 is 1. Okay, we pick 3 candidate, so we know we pick 3 candidate, 1 2 3 4. Now we first check candidate 1. Okay, number 3. We find first occurrence of 3. Okay, first occurrence of 3, so see, left is equal to 0 0 1 2 3, and right is equal to 3. So we find mid, so mid is 1, so array of 1 is 3, so we save 1, we go left. Okay, so left is 0 and right is 0, so mid is 0, array of 0 is 3, and we save 0, so we go left, so left is 0 and right is negative 1, so we stop, so the first occurrence is 0. Okay, the first occurrence is 0. Now we find last occurrence of 3. So left is 0 and right is 3. Okay, we find mid is 1, so array of 1 is 3, we save 1, we go right, so now left is 2, now right is 3, so mid is 2, so array of 2 is mid, the value is 3, so we save, we go right. Okay, so the left is 3, right is 3, so mid is 3. Okay, mid also 3, so array of 3 is 5, so we go left. Okay, so left is 3 and right is 3, so we stop, so the last occurrence is 3, first occurrence is 0. See, last minus first plus 1, 2 minus 0 is 2, plus 1 is 3. Okay, 3, so 3 is greater than 1. Yes, so the answer is 3. We picked array of 1 3 as candidate, we found first occurrence 0 and last 2, so we count 3, so 3 is greater than 1, so we have to return 3. Clear? Now see, now let's write down the code. We need two functions. Okay, let me first write and I will explain you. See, first we need two helper function. Okay, so why we need helper function? We need to count each element. First to count, we need first and last positions. Okay, so we make two functions, first and last. Okay, see, first function is find where a first time it appears. Okay, now we write down the code. Ouch. Now let's send down the code. And first first VECTOR Victor in and nums in target. Now left is equal to 0 and right is equal to nums dot size -1. Start from beginning, end at last element. Okay, we are starting two pointers, and in lizard is equal to -1. -1 means not found. Okay, so we take our while loop while L is less than or equal to right. Now we find mid, and mid is equal to left plus right minus left divided by 2. Okay, divided by 2. Now if nums of mid is equal to target, then store we store result in mid. Found but maybe a real one exists, so that's why we store mid. So right is equal to mid -1. Now else if nums of mid less than target, left is equal to mid +1, else right is equal to mid -1. In last we have to return the result. RETURN return RESULT result. Okay, so first occurrence we have write, and we have to write last occurrence also. We just copy paste this only. Command C, command V. Instead of right we left plus, and first not, it was last. Enter. Okay, so same we have write for last also. Find where last numbers has appear. Okay, only one line is different. This line is only different. No, this line is different. Okay, let me clear. Next we have to write here. Just a minute. Okay, see, now we have to get price, and n is equal to array dot size. We have to pick 3 elements. 3 element means this candidate. I have created we have, you know, why we have to want the tree candidate. Instead of writing full name, we just written 1 is equal to array of n divided by 4 element of last boundary. Okay, and 2 is equal to array of n into, I think n 2 into n divided by 4 element at second boundary. Okay, and 3 is equal to array of 3 into n divided by 4. Okay, because special number must appear at one of this position. Okay, we need this 3. Now we check. I think first we have to try them. I think we have to write first or try them. No, first we write C. And first is equal, no, because first is the function name, we use f is first. Okay, first array and 1 where does it start. Okay, and end last, last last array and 1. Now if last minus first plus 1 greater than n by 4, so return 1. Okay, now for 2 also we write same, and f is equal to 5 lst first array and 1 where does it start, and end last is equal to last. Okay, array and 1 where does its end. Okay, next we find if last minus first plus 1 greater than n by 4, return 2. Now same for 3 also. In first is equal to lst first array 1 and last is equal to last array 1 where does its end if left minus first plus 1 greater than n by 4 return 3. Okay, if answer is not, we just return -1. Okay, now see. Okay, and first function find starting position first and ending position first. Okay, for first we are going to use this, and n by 4 means 25%. Okay, boundary positions, and where is that formula? So this means count how many times it appears. Okay, n by 4 means more than 25% is if we have to return. Now let's try them, then we get it clearly. if we have array like, let's take small example, 3 3 3 5, so the n is 4. So how many elements are in array? So there are 4. Okay, first see, int 1, okay, is equal to array of n by 4. So we pick one subset n by 4. If n by 4 means 4 by 4 1, so array of 1 is 3. 1 2 3 4, 3. So the 1 equal to 3. Now see first, first, in first and array and 1. So where those 3 start, 3 first appears. Okay, so in binary search, run, see, first is equal to 0. In last, where those 3 has appeared last. Okay, so the binary search, there was the position is 0 1 2 3. Okay, we use this index 0 1 2 3. Last is 2. Okay, so we use this 2 minus 0 plus 1. 3 minus 2 is 1, so 3. So 3 is greater than 1. 3 is greater than 1. So okay, we return 1. So 3 is our answer. So see, if we have array 0 1, okay, so see, 3 has picked subset. First is 0 3 and count is 3, so 3 is greater than 1, so the answer is 3. Okay, so it was clear. I think it was clear. Where is the error? What is this here in first? To write that variable name first and then we have to return. Let me clear this. First let me try them first, then I understand clearly. First let me try them. I just to change the variable name. Okay, so if I have array 1 2 6 6 6 6 7 8 0 1 2 3 4 5 6 7, so there are total 8. I start executing my code from the top. Okay, so see this. Okay, this means I am just counting how many elements are in my array. Okay, so there are, so the n is equal to 8. See, now this line int 1. So int 1 means I am picking my first subset. N by 4 is equal to 8 by 4, that was 2. So I go to index 2 in my array. Okay, I go to index 2 in my array. So array of 2 is 6, so my first subset is 6. Now see, now this line. Okay, let me write first one, last one, first 2, last 2, first 3 and last 3. Okay, so see, now I call my first function. I go to this line and we call this function first function. So I'm asking where those 6 appears in this array. So let me try first function. So see, left is equal to 0, right is equal to 7, so the result is -1. So see, mid is 3, array of 3 is 6, so 6 is equal to 6, we save result, we have to save from 3. Now we go left because maybe earlier it was exit, so right is equal to 2. Now mid is 1, so array of 1 is 2, value is 2, so 2 is less than 6, so we go right, so left is 2. Now see, now mid is 3, now mid will come, mid is 2, so array of 2 is 6, so 6 is equal to 6, we save result by 2. So we go left, so the right is equal to 1, so now left is 2, right is 1, so is greater than, so we stop. Okay, so first function return 2, so 6 first time appears at index 2 only. Okay, now last one, when last it appears, so see, now left is 1 and right last one. Okay, array and 1. Now I call my, see, now I call this function last function. Okay, so I am asking where those 6 last appears in this array. Okay, now left is 0 and right is 7, so the result is -1. So see, now we find mid is 3. Okay, mid is 3, mid index 3 and value is 6, so the 6 is equal to 6, so we save result, we update -1 instead of 6. Now we go right because maybe 6 is 6 later, maybe because 6 later 6 exit. Okay, now see, left is 4, now left is 4. Now see, mid we update, now mid is 5, so array of 5 is 6, so 6 is equal to 6, we save 5. Okay, now we go right, so left is now 6, now mid is equal to 6, so array of 6 is 7 is greater than 6, so we go left. Okay, so the right is equal to 5, so now left is 6, right is 5, so is greater than, so we stop right, so last function return 5. Okay, so 6 last time appears at index 5 only, so the answer is right. Okay, now we go here, now we come in this line. Okay, now we calculate this line, so now I know, so the array of 6 is first time appears at index 2 and last time appears index 5. So 6 goes from index 2 to index 5, so let me count index 2, 3, 4, 5 also, so there are 2, 3, 4, 5, so there are total 4 elements. So the formula is last minus first plus 1, so last is 5 minus first 2 plus 1, 5 minus 2 is 3, 3 plus 1 is 4. Now check is 4 is greater than 25% of 8, so 25% of 8, it is equal to divided by 4, so 2, so 4 is greater than 2, so yes. Okay, so now we return 1. Count cross 25, so 6 is our special numbers, now we return 6, so the answer is 6. Okay, now see, and now how those code works. Okay, so we did not, so see, we did not even need to check these 2 and 3 because we found our answer at suspect 1 itself. Okay, that's how it works. See, now let first try this. Just left 1, left 2, left 3. Now what is it? Left minus wait, left last one and first one, last two and first two, last three and first three. Answer is wrong. Output is -1, accepted is 6. Why the output is wrong? Shift is mid-press 1. If array is right, array is greater than right. And we have got from this, so it was birds. And last target also same as same, and if is remove, so the test case is wrong. If n is divided by 4, 2 2 1 2 2 6 6 6. This example only. Wait, let me try to. I think so. See. It was going 1 1 2 2 3 THRE THRE. Now let me see. So I have to write these names. Okay, the code is right. So see, in F, first two and last two, first tree and last tree should search for 2, and so it's searching for 1 only. So okay, let me clear here. First two and last two should search for 2. Okay, I have write 1, so it was searching for 1, so that's why it was wrong. And first 3 and last 3 also search for 3, so we have accident. So I was searching for 1 or 3 times, that's why it given error. Okay, so the answer is right. See, so see, the array is sorted. Whenever you see a sorted array, okay, like 1 2 3, whenever you see a sorted array, always think binary search. Okay, and if array is sorted, always think binary search. And next is 25% means 4 parts. Okay, 25% means 4 parts. 25% is equal to 1 by 4 and divided into 4 parts. Okay, special number must appear at one of 3 boundaries. Okay, and second formula we have the last minus first plus 1 means how many times number appears. Okay, always 1, because first index also count. So why we have take only 3 subset? special number appears more than 25%, so it crosses at least one part boundary. So that's why we check array of n by 4 and array of 2 n by 4 into, okay, and array of 3 n by 4. So the time complexity of binary search is big O of log n. It was very fast. Okay. Now let me show you how this formula work. Okay, see, this formula tell us how many times a number appears. So we have take 1 plus, let me show you why. See, we have 1 2 6 6 6 6 and 7 8. Okay, so the 0 1 2 3 4 5 6 7. So the first 2 is index 2. So the 6 has come first time in index 2 and last time index 7. So 6 is at index 2 3 4 5. So count them 2 3 4 5. So there are 4 elements, 1 2 3 4. Okay, 4 elements. So see, last minus first is 5 minus 2. No, 6 has come here. It's not 6 has come in index 5. So it was 3, so it was wrong. So last minus first plus 1 is 5 minus 2. 5 minus 2 is 3. So 3 plus 1 is 4. So they are total 1 2 3 4. It was correct. Okay, whenever you count element between two index, always add 1. Whenever you count elements between two indexes, so always add 1. Okay, so now let's see 25% of, so that means 4 parts. Whenever you see 25% in problem, immediately think 4 parts. Okay, now see 25% is equal to 25 by 100 is equal to 1 by 4. So 1 by 4 means divided by 4. So divided your array into 4 equal parts. Okay, so I divide your array in 4 equal parts. Like see, let me take this example only, 166. So they are total in part 1 1 2. Okay, index 0 1. In part 2 6 6, index 2 and 3. In part 3 index 6 6 4 and 5. In part 4 7 and 8. So index 6 and 7. Okay, special number appears more than 25%, so it take up more than one part. That means it must show up at a part boundary. Okay, so boundary 1 is subset of array of n by 4. Boundary 2 is array of 2 into n by 4. Boundary 3 is array of 3 into n by 4. See, you see 25%, think, whenever you see 25%, think 4 parts. Okay, check their boundaries. So yes, we have take two functions. I have created two helper function, first function and last function. This function finds where a number first appears, okay, where the first time 6 has appears, and where the last time 6 has appears. So that's it. So it works. Okay.